Alright, so again the next step is to solve this problem in the static structural, and also similarly as we did for the previous case where we had duplicated a copy of the geometry file. So in a similar way again I am going to copy this file, and this would be the cooling tower for the static structural. Okay, now simply drop this geometry cell on the geometry cell inside the static structural and double click here on the geometry. We will not be editing geometry from here, but we will editing geometry from here. And once we edit geometry here, this will automatically be updated in the geometry cell inside the static structural. Okay, geometry is open inside the static structural, so I just wanted to confirm these boundary conditions. And also on the bottom side, we have to provide the boundary conditions as a supports. So because this part will be exposed, means that this will be the part of the FEA simulation. So we'll choose these surfaces, and I put as the cooling tower fixed support. Okay, now simply save this project and close this file. Now to just confirm this thing again, I am just opening this file once again. Yes, I can confirm that these boundary conditions are there. So I will close this geometry cell, and next thing is to make the mesh and the other settings for the geometry. So I will double click on the model section, and now this is starting the mechanical portion of the Ansys. Okay, so first of all, here you should be checking the geometry file first, and also name selection. So we have these all parts with us. Okay, so the first thing we should be doing is the mesh. So I will right click here and click on insert method, choose this whole geometry, and this is going to be the tetrahedrons. And also make sure that we have the mechanicals selected. Okay, next thing is to put the sizes on the different parts here. So different surfaces, I will be putting mesh size. So let's say I start with the size as a 1, and now simply click on generate. And this is the mesh after this setting. So I think that the mesh is very fine on these surfaces, and mesh is very coarse on these sides. So I will be putting the size as the 2 for these, and for this top boundary and the bottom boundary, I am going to put the size as the 0.5. And again I will be recalculating the mesh. So click on the mesh and click on the generate. I guess the mesh on the top side and the bottom side of this geometry is well done, but the mesh here is a little bit coarse. So what I will do is that I will be making the size as the 1.5, and on these sides I will be making size as the 0.7, and again I will generate the mesh. So we have the now decent mesh on these 4 surfaces, the top, bottom, inside and outside. But the mesh sizing on these supports is not, they are very coarse mesh sizes. So I will be choosing the mesh size because these are too many surfaces here. So I will be choosing from the name selection. And this is the cooling tower fixed support. And I would be putting size as a 0.2. And the second one I would be making the mesh size would be of these bottom supports. And again I will choose from the name selection, and this time the boundary is the cooling tower fixed support. So the same size which I did for the previous one is the 0.2. So here we have the 0.2. So I will now again calculate the mesh. So click on update or generate. Still I find the size on these circular parts is not are of the good quality. So I would be changing this size to the 0.1 and again I will try. Okay, so finally after these settings, like you can see that we have the size as a 0.2 on the bottom sides, and for supports we have the size as the 0.05, and here the size was defined to be the 0.3, and on these inner and outer parts of this cooling tower the size is 1. And for this inner and outer surfaces the size is 1.5. Okay, so we will close this application here, and then in the next step we will set up the fixed supports, and we will import the pressure from the CFD part.